Good afternoon. My name is Ekaba Bisong, and I'm a data science lead at T4G. So T4G is a data consulting company up north in Canada. So I was like, came in from Calgary earlier as of this morning, and so today briefly we'll be talking about using machine learning to detect or assist in detecting toxic language on online forums. And I think when I came in, I heard, is it someone, Toga or so, from the Google Brain team talk about the Jigsaw data set. So that's the exact type of data set that was used in this project, or when I call it, this is a weekend project anyway. So, but the cool thing here is to kind of promote how we can leverage auto ML on GCP for building actual data products that can make an impact in the society, really. So there's a challenge of moderating of pruning online communities. One is that it can be time consuming, and looking out looking at charts or images or videos or whatnot, and also there is an issue of consistency in judgment. As far as we have two people, even two twins, who would make two different judgments, talk less of having 1,000 people or tens of thousands of people having to make a judgment of what is toxic and what is not toxic. And another challenge is the psychological harm to the moderators. Now, if you imagine for a second that you're looking at tons of beheading videos every day or tons of obscene photographs, it does a lot of damage to the mind. I mean, even taking a look at the Jigsaw, this is a Jigsaw data set, it's a text data set. Just looking at some of what was labeled as toxic words, reading some of them, my mind took a beating. It was not some of those words, those sentences are a bit, intense. Have to do a mental cleaning after. So this is some of the challenges in this sort of moderating. So then I'll go on to talk about the case for AutoML. Now, what they call AutoML, it encapsulates three concepts, broadly speaking. And the first is the concept of transfer learning. Now, as we all know, building machine learning models, large-scale models, can be extremely computationally, can be computationally intensive. And so it will make a lot of sense to leverage pre-built models and then use it in solving your own domain or use case. So that's the moonshot idea of transfer learning. So how it works is it takes just the layer before the output layer, and then which is called the bottleneck, and then you train that layer on your own data set. So you're leveraging the weights or the already understood parameters of a large-scale network in your own data set, and that's how that works from a high level. And the other is what is called neural architecture search. It's a fancy word, but it's really very interesting, and there's been around for a couple of years now, probably 2 or 3, I can't remember when. But then the idea here is to how can you build, because part of the challenges of building a large-scale network in production is, one is to find out what's the best architecture for my use case. In line with the idea of a no-free lunch, there is no silver bullet ML architecture. So neural architecture search is using the idea of a learning agent, a reinforcement learning agent, that where the actions it's taking is proposing certain set of layers for the network. And then the idea is you want to optimize some utility, and that could be the performance index of the model to decide which is the best architecture for your problem space or for your use case. So that's what neural architecture search is. And then the other is hyperparameter tuning. To take any method. So it's a neural network, or let's say linear regression method. There are a set of parameters that you may need to tune. A common one would be could be a learning rate, or some metric, some method, some parameter you want to tune. How can we tune this at scale? So you're handling three things. You're trying to find the best hyperparameter. You're trying to find the best architecture. A lot of things going on. So that's where AutoML comes in. And GCP, that's Google Cloud Platform, they have a product called GCP AutoML for NLP, for natural language processing. So it packages these concerns into a product and trains on scale. So you have Google's massively, parallel distributed machines available for you to load your own data set, process it first, load it, and then train. So that's what we did with the Jigsaw data set. So there's a method for preparing it. I would just gloss over that. I'm waive that for this talk. So I'll just say that we upload the data set to AutoML for natural language, but it has to be processed or developed, arranged in a particular format. And the next, as you see on the screen, then the next thing is that we train it. And the longer you train, of course, you could have it better, depending on the size of your data set anyway. So it trains it, you do the training, and then the model is deployed. Now, in the deployed model, you have a user interface where you can kind of validate, evaluate your model. And there is, I can't see what I put there, but there's an example of a toxic or a clean set, and it did pretty well. But of course, there are obvious limitations. It's one thing you're asking when you talk about toxic and clean. I would, it doesn't understand things. There's a lot of issues when we talk about context. And let me play around with a funny context. Like someone can say, use the F word on the current president. Many people will think it's toxic. Others will think, a lot of others will say, that's not toxic. Yeah. Now, well, whichever divide you lie, that's up for the jury. That's part of the issues of this kind of stuff. And that can use the F word on the previous president. A lot of people will think that's toxic, and a lot more will say that's not toxic. But that's where you are, and that's the word, and it's okay. It's okay. Those differences of opinion, it cannot be otherwise. So, but this is trained. I would say this makes sense in moderating what is clear and obvious. And I think this is part of the thin line we need to toe as AI researchers and developers. And I think my friend Wally talked about AI for social good. These are some of the things that, or AI ethics, some of the things that we should look at in terms of how we draw the line between having our online community safe for us and then going to another length of what we will call intellectual or speech fascism, groupthink of how you should think or say. So freedom is important, but being cordial, congenial, and these are some of the trade-offs that I think that, well, this is more in the arena of wisdom. So those are some of the limitations of this. But what is clear and obvious, I think it does pretty well. Now, the goal of this is to say that there are opportunities for products, leveraging this kind of opportunities for downstream software products or applications that leverages this infrastructure on Google Cloud Platform. There's an object detection, AutoML for object detection that just came out, I think, by the early part of this year. I'm not too sure, but the image classification one has been there. These things can tie together, and it exposes endpoints, which you can infuse into your software pipeline, product pipeline. So there are a lot of opportunities here, and we could talk, and these things can be leveraged to create products that improve the society. And the meat and bones of how I built this, it's it's part of a chapter in that book you see up there. So it's a book that it's available for pre-ordering, but it's will come out October, I guess, mid-October. So building machine learning and deep learning models on GCP. And thank you so much for your time, and it's a pleasure to be here.